Alright guys, welcome back to a new lesson. Today we are starting a new lesson series on transformations. So this is going to be part 1 of another 3-part series, and this is our last lesson series of the year. Alright, so we're going to start talking about transformations, and today we're going to focus on some definitions and an example of one type of transformations. So first and foremost, what is a transformation? So a transformation is just a process that manipulates an object on a coordinate plane, which is a plane with an x and y axis, or a graph. That's how we're used to referring to it, but it's called a coordinate plane. Alright, so within transformations, they fall into 2 different categories. The first is a rigid transformation, and in rigid transformations, our size and shape stay the same, so they do not change. Alright, and this is contrasted by what we call non-rigid transformations, where our shape sometimes stays the same. So we're going to write it as can stay the same. But our size sometimes will change. Alright, we have 2 types of rigid transformation, non-rigid transformations. We have our dilations and our stretches. So for stretches, our shape changes slightly. It's going to get longer or taller. But for dilations, they just get bigger or smaller. Alright. Our 3 types of rigid transformations, we have the first one is called a translation. Then we have reflections. And rotations. Right, so we're going to learn about all 3 of these, but today we're focusing on translations. Circle that and highlight. Alright, so again, just a quick reminder, rigid transformations, our shape and size stay the same. So that means that the shapes that we're working with are going to move around our coordinate plane, but they're not going to change their shape. Alright, so a translation is going to move each point of a figure by the same distance in a given direction. Alright, so these directions are going to be given to you in 3 different ways. Not all at the same time, but these are the 3 different variations that you're going to see. So we have explicit directions, which tell you exactly how to move. So this one's telling us to move 3 units up and 2 units to the left. And just for reference, a unit here is one of these boxes. Alright. Transformation notation, also known as an arrow notation because of this dandy arrow here, is written out like this. So this is our original. And these are the changes that it goes through. So in this example, we are subtracting 2 from our x and adding 3 to the y. And displacement tells us that, again, we're subtracting 2. And then because there's no sign in front here, that means that we're adding 3. So these 2 here are specifically referring to the coordinate points. Alright, but all three of these are going to move our shape the exact same way. Alright, so we're going to show this example here. So we have our original shape A, B, C. I wrote out our coordinates here. We're going to do our explicit directions first. So we're going to move 3 units up and 2 units to the left. So I'm going to go up 1, 2, 3, to the left 1, 2. So this is going to be my new point A, which I'm going to name A prime. That's what that apostrophe means. Then we're going to do point B. I'm going to go up 1, 2, 3, and to the left 1, 2. And this is my new point B, or B prime. And lastly, we're going to do C. So I'm going to move up 1, 2, 3, to the left 1, 2. And this is my new C prime. Alright, and then we're just going to connect it. Connect all 3 of our points. And as you can see, the shape is the same. We just moved it a little bit. So I have my coordinate points written here, and we're going to use this displacement and transformation notation to see if our translation is correct. This point is not correct. That's not -4. It is -2, because we're only 2 away from the origin. Alright, so to each of these points, I'm going to go through. I'm going to change this to blue. Alright, so I'm going to add 2 to all of my x's. No, subtract 2. And add 3 to all of my y's to get my new coordinate points, and we're going to use that to check to see if we have our coordinates right. So this means that my A prime should be my B prime, should be -4, 4. Alright, my A prime should be 1, 7. And my C prime should be 1, 0. Right, now I'm going to go through and write out the coordinate points. So for point A, I'm at 1, and 1, 2, 3, 4, 5, 6, 7. So this one is correct. For B, I'm at -1, 2, 3, 4. Alright, -4. And 1, 2, 3, 4 up. So that one is also correct. And for C, I'm at 1, 0. So that is also correct. So you can use each of these notations to check that your work is correct. But if you get either one of them, you should be able to get to the right answer. Alright, so you're going to see translation examples in 3 different forms, the types of questions that they ask you, that is. So the first is going to tell you to graph the image. So here we have an example of our explicit, where it's telling us exactly what to do to each point. So it's telling us to move to the right 4 units and down 2 units. So you can start with whatever point you want. I'm just going to start with point A. So here I have 1, 2, 3, 4 to the right and 2 down. 1, 2. This is my new A prime. I'm going to do the same for B. We're going to move 1, 2, 3, 4 and down 1, 2. For my B prime, same with C. 1, 2, 3, 4 and down 1, 2. For D, we're going to go down. We're going to go right 4 units. 1, 2, 3, 4 and down 2 units. 1, 2. And this is my D prime. Last step is just to connect those 4. and you should have the same shape, just in a different position. All right, easy. So here we have an example of our displacement, which means we're looking at the coordinates of each of these points. And we are subtracting 1 to every x and adding 2 to each y. Alright, so let's start by writing these coordinate points. Let's use this pen. So A is at 1, comma, negative 2. And then we're going to write it off to the side here. B is at 1, 2, 3, 4. Negative 1, 2, 3. We're going to write that here. And C is at 2, comma, negative 1, 2, 3, 4, 5. We're going to write that here to the side. So we want to find the new coordinates. So we want to find the coordinates of our A prime, B prime, and C prime. So we're going to subtract 1 from every x, and we're going to add 2 to every y. Alright, so that means that A prime is going to be 1 minus 1 is 0. Negative 2 plus 2 is 0. So that is my new point for A. B prime is going to be negative 4 minus 1 is 3. Negative 3 plus 2 is negative 1. And C prime is going to be 2 minus 1 is 1. Negative 5 plus 2 is negative 3. So these are my new coordinate points. I don't have to graph it because that's not what the question is asking for. It's just asking for my new coordinate points. So that's it. We are done. All right, and the last example is going to be like this one, where we have the transformation given and we have to write the rule ourselves. So here we have it set up for our transformation notation with our arrow. So I'm going to start with my parentheses, and let's see what is happening to each of my x's first. So I'm going to write these coordinate points, or actually let's just look at the position. So I'm moving 2 to the right for each. So I started here and then I moved 1, 2, started here and I moved 1, 2. So if we move to the right, that means we're adding to each of our x's. Alright, now let's look at our y's. So I went 1, 2 over, and 1, 2, 3 down. So remember, down means negative. So to each of our y's, we're subtracting 3. And this should be true for each of those points. So we can go ahead and go check those. So B, do I go plus 2? Yes. Down 3. There's 1, 2, 3. So that one's good. C, let's change to green. Go 1, 2 to the right. And 1, 2, 3 down. And D, we're going to go... let's do blue again. Over 2, 1, 2, down 1, 2, 3. So that means that this rule applies for each of my points, and this would be my answer. Alright, we are done for today. These notes are going to be up on our Google Classroom, and this video will be posted as well. Make sure to complete your exit ticket and your IXL practice. I will see you guys next week.